Documentation, you must scan your badge at the iPad in the back of the room at the end of the session. Our opening session speakers are both from Amazon Web Services. We have Merritt Bear, Principal Engineer for AI/ML, and Hayes Magnuson, Senior Navy Account Executive. They'll be talking about Coalition Interoperability and Security on AWS. Please join me in welcoming our speakers.
Great. Hi, good morning, everyone. First and foremost, thank you so much for taking the time to join us for a bit this morning. We are going to cover a pretty significant amount of topics regarding the AWS cloud. What we'd like to do, especially since this is going to be a bit more of an intimate setting, please feel free, as we're going through the slides, to interrupt us, ask questions. If there's things you want to know more about, we are happy to make this as discussion-based as possible. If there's anything that you would like to know more about that dives a little bit deeper, both Merritt and I are going to be here through the end of the week, and we are more than happy to entertain questions after this session, and then also over at the TechNet conference, we have a booth with some demos that we'll be discussing as well. So I'll let Merritt start us off here, but just real quick on my side for introductions. My name is Hayes Magnuson. I am the West Coast Navy Account Exec at AWS, covering NAVWAR and US Indo-PACOM. I've been in this role for the last 3 years, and I am a former surface warfare officer, so I did spend some time at active duty in San Diego and out in Hawaii as well. So very much appreciate the opportunity to support the Navy in this role, and very excited to see the Navy and the coalition forces and their adoption of the cloud. So we'll dive into those topics here today. Mayor?
Awesome, thanks. Good to see everyone. Welcome. You guys thrilled to hear a little more about cloud? Good, yeah. My name is Merritt Bear. I'm a Principal Security Architect at AWS. For the last couple years, since I came, I have been working with the Fortune 100s and advising them on their security around the world. And I am now working on strategic initiatives in worldwide, including public sector. So as Hayes mentioned, please come talk to us afterwards if you have questions or ideas for things that we could be working on. We do a lot of our, our drive comes from specific customer anecdotes and questions. So please bring us your feedback. I came to AWS from US government work. I've worked in all 3 branches doing security on behalf of the American people. So again, we're happy to be here and happy to kind of make this as interactive as you like. So feel free to raise a hand if you want to talk a little more or ask a question.
Great.
All right. So we're going to start off by talking a little bit about the infrastructure that underlies. AWS came about in 2006 when Amazon.com realized that they had built out this core capability in building and maintaining large-scale physical infrastructure. So as you look at this slide that lists some of our significant customers, one of the things that comes to mind is that 10, 15 years ago, and even today to some extent, folks had to actually maintain their own data centers, right? And so you're talking about racks and stacks and cables, and the reality of trying to maintain and operate and secure those kinds of environments was a really heavy lift, and it was undifferentiated heavy lifting. So everyone had to do it, even if you were in the healthcare industry or in the government security industry, you still had to be in the data center industry. And that is no longer true, of course. The basic premise or the basic value proposition with cloud is that you get to kind of outsource that headache, those bottom layers of the stack, from the concrete floor up through layer 4, the hypervisor. And then your application layers, so layers up through layer 7 of your software stack, are where you're doing application layer stuff and you know what you're doing, and then we can help you with it. So that being said, we have global infrastructure, and obviously this is relevant when you're talking about what kinds of activities you're trying to do. So this is a list of our current regional footprint, but it's kind of cooler as a map. So we're looking at, we can overlay here some of the basic footprint and how it has been changing. Go ahead.
Great. And so what we like to highlight here is that the rate of expansion that we have for our global infrastructures is really just astronomical. You see the first few years that Amazon was in existence, we had a few points of presence, mostly in the US. And we've grown just absolutely exponentially since then, most notably in the last few years, where our region expansions have been considerable in the AOR that I think is most relevant to this group today. So yeah, if you take the opportunity to see both where our existing infrastructure is and then also where our planned infrastructure is, it is being driven in a large part by this geographic area. We have many of these regions that are, all these regions here are already built. We have plans for several others. We announced, I believe, Spain, right, is going to be coming online here sometime in 2020. And we should see, I'd expect some probably additional announcements here when we have our user conference in Vegas in about 2 weeks. But we just want to make sure that one of the areas that we like to highlight is we have these regions that are available for your use that anybody can use. You can truly go global in minutes from your own PC right now. Any of you can go to aws.amazon.com and launch compute and storage and database resources in any one of these regions right now because it is globally connected via the AWS backbone, which we'll show here in a bit, but it gives you the ability to be able to get closer to your mission owners and get the resources that you require to be able to accomplish your mission. And the uniqueness of that is the resources in those regions are the exact same, whether you're operating in Australia or the US or South Africa. The compute, storage, network, database, and then higher level services are going to function the exact same, which is a pretty unique capability.
Awesome. Yeah. So this highlights some of the elements that we are taking off your plate, including custom hardware. Going back to 2012, AWS acquired a company called Annapurna Labs, and now they have been the underpinning for our development of custom hardware. Everything from silicon to the Nitro architecture, which underpins all of our EC2. We're going to talk a little bit more about that in the security slides that I have coming up. But if you go to infrastructure.aws, I think it was on this, well, one of these slides. But if you go to infrastructure.aws, which actually does resolve on a phone and everything too, it'll show you these maps of points of presence. You can click on custom hardware and get more information. It's really neat stuff, especially for those of us who are, tech geeks. Looking at what we used to expect was just kind of the landscape of hardware that everyone had to accept, and that we're actually customizing and therefore externalizing some of what have been operational and security problems that we are now turning into hardware solutions. Go ahead, you want to do this?
Yeah, sounds great. So one of the things that we like to highlight is when we talk about a region, we're talking about a very unique to AWS capability, where when you think of a region, all we're really describing is just a theoretical geographic area. The region itself is actually broken down into logical elements called availability zones. These availability zones are where we have one or more of our data centers that are interconnected across the availability zones with very high speed, very low latency networking, so that you, the end user, it appears as just one gigantic data center, but in fact, you're actually able to access services or deploy applications yourself in a very highly resilient manner.
Yeah. Our CTO, Werner Vogels, always says, everything fails all the time. So that being said, you architect for failure, right? And this was true when you were maintaining your own on-premises, data centers. It is true in cloud that you want to make sure that you have architected for resilience. And one of the ways that we just do that inherently is that when we have these points of presence, those are not individual data centers, those are clusters. And so we talk about availability zones as a series of data centers. And of course, we have also, in taking those bottom layers of the stack, we've taken considerations like floodplains and, all of the kinds of considerations you would want to make around a high availability, architecture. This is just kind of reiterating some of the things that we have mentioned: meaningful distance for separation, independent infrastructure, et cetera. So you will have, service level guarantees of what you should expect from resilience on our end. You can also architect for increased reliability and increased security on your end. Do you want to talk about? I don't really.
No, so what we like to highlight here is, so the global network itself is completely connected with Amazon's own private fiber. So you have the ability to go global in minutes via either our regions themselves, or also we have our edge locations. So essentially content distribution networks for caching at the edge to be able to make applications more performant. We have, I believe now, last count, it's over 180 edge locations in addition to our global regions. So just an absolutely very diverse and very spread out footprint that you can be able to leverage these services.
And the way you'll experience that is, let's say that you spin up an instance in Sydney and in Ohio today. The first time that you grab something that is located in that region, you may experience a couple of seconds of delay. The second and third times, it's cached at the edge. So you're going to see less and less latency with the items that you touch more. And that's true as a characteristic in some of our services. So for example, DynamoDB, which is our database, our proprietary database, as the things that you touch the most will be the quickest to resolve. And so it's kind of counterintuitive in that folks expect that there might be latency when you're grabbing things time and time again. It's actually faster.
So we talk a lot about our global regions now at this point, but for this specific audience, we tend to narrow the focus down to be able to showcase that we have regions that are specific to our sensitive customers' workloads. So today, we talked about our global commercial regions, of which we have 22. Right? We also have regions that are available for more sensitive workloads. It's important to note that the DoD today does use our commercial regions. As I said, I'm the Navy account executive, and we do have a program in the Navy called Open. Some of you may actually know some of the team from the Open program because they're mostly based out of Hawaii. But all the public Navy websites today run inside of the AWS commercial region US East. So if you go to the Blue Angels website or public.spayawar.mil, you are actually going to AWS today in a completely accredited Impact Level 2 environment for publicly available data. Going up the sensitivity stack, we have two regions for ITAR-related export-controlled data sets, which we call GovCloud. These are not regulated just to government customers. They are available to customers that have needs to host sensitive data sets. So things like CGIS and HIPAA and PII and PCI and on. We have regions that are completely isolated from that are architected to be able to host those types of sensitive data sets. Specifically for the DoD, we talk about impact levels. So DISA defines DoD data sensitivity on the unclassed side through this model called impact levels. So impact level 2 is publicly available data, which I've just described kind of as the open program. Impact level 4 is for FOUO CUI type data sets, and impact level 5 is for unclassified national security systems. Today, AWS can host FOUO CUI and unclassified national security systems inside of GovCloud, the region of which we actually have two, GovCloud East and GovCloud West. GovCloud West is in Portland, Oregon, and GovCloud East is in Columbus, Ohio. We today have many dozens, if not hundreds now at this point, of DoD resources at impact level 4 or 5 running in production in the cloud today. Continuing forward, we also have the Amazon secret region. This again is architected the exact same way that we described previously, with multiple availability zones and multiple data centers per availability zone connected directly to SIPRNet. So DoD team members and members of the IC community have the ability to deploy secret workloads inside of Amazon and leverage services that are accredited to run those data sets and workloads. But lastly, we have the C2S region, which is our JWICS connected top secret region, which has been being leveraged by the Intel community since 2013, and also by DoD customers, largely by exception, that have relationships with Intel communities or either SIGINT or ISR mission sets, but that we do have the capability to also host TS-SCI data and have services accredited for that as well.
Yeah, it's also, I think it's relevant to point out that the security of GovCloud is not any different than the commercial cloud. From a security perspective, they are both secured by the same technologies. This is a regulatory and compliance regime that we can satisfy. But in terms of the kind of high water level of security that we provide, that's across the board. So the same custom hardware, the same tools and levers that customers can use to architect for security and reliability.
And I think that's a great point as well, is that the services are no different inside of these regions. So if you're accessing services in GovCloud and you want to deploy into secret, as long as the service is available in the secret region, it will operate the exact same as it does on the low side. Conveniently, we also have a managed service called AWS Diode, which is a low to high one-way CDS. And so and that has been in production for a pretty significant period of time with the IC community leveraging that from both the commercial to high side, and now we have from GovCloud to secret and GovCloud to top secret. The only major difference of the regions is who runs the region. So in GovCloud, to be able to meet requirements for Impact Level 5, all the folks that plug in the servers and all the folks that support the actual services themselves are U.S. citizens on U.S. soil. And then in the secret and top secret region, obviously, then they have clearances in those regions. Great. And this is just to reiterate, so we, for the DoD customers, are held to the standards of both FedRAMP and DISA's DoD Cloud Computing Security Requirements Guide. They call the DoD SRG. So we have the ability to show our services to third-party authorizing officials that then validate that our services meet the NIST controls to be able to host DoD data sets as defined by both DISA and FedRAMP. And FedRAMP has the DoD CIO sitting as one of the Joint Authorization Board members. But we also have multiple other compliance regimes that we adhere to as well. So we noted CGIS and HIPAA and PCI and PII and SOC 1, 2, 3 and on. So we have these services that we are reviewed against on a very consistent basis to be able to show our customers with sensitive data sets that they can operate effectively inside of the cloud.
And we also work with a number of foreign governments. So, you see UK on here, we work with Australia, et cetera. So I know that part of the Coalition Interoperability Forum premise is that we could be doing information sharing in kind of ephemeral environments that we spin up. We're already certified and working with a lot of allies around the world, and so this is kind of a natural, we already have the building blocks in place here from a compliance standpoint.
And one thing to know that's actually very exciting, so DISA did just accredit multiple new services of Amazon's for both Impact Level 4 and 5. That just happened at the start of the week, but in the direction that I think the DoD is really headed. So we had multiple sets of our container services accredited inside of GovCloud for both Impact Level 4 and 5, and even I think more exciting still is our serverless technology, AWS Lambda, which developers have been asking for pretty much since it was created a few years ago to be able to access for secure, more sensitive data sets. That was also accredited. So we can dive a little bit deeper into what those services are, but I think if you do have any software development needs, you should be really excited about these new developments, and those will be accredited through the end of the year until we get the end of 2020 until we get our extension letter.
Cool. So I'm going to dive a little deeper here on the security around our platform, in part because everyone here is in some sense in the sort of vertical of security work, and also because no one is going to do anything in the cloud unless they believe it can be secure, right? So we have some of the most sensitive workloads from the most sensitive customers, from banks to healthcare and pharma organizations to governments and you name it, it runs on AWS. And so obviously security is a foundational consideration. It is also, of course, a foundational consideration for Amazon.com, who we basically consider to be one of our external customers. So these are some givens now that we're talking about cloud scale security. One is infrastructure as code. I'm going to talk a little more about this, but this basically means that, whereas in a previous life with your on-prem data centers, you had to worry about the rogue server under someone's desk. Now, you interact with the console. How many folks in here have logged into a cloud console? Okay, so a fair number. So you know how it is. You log in, you experience a UI, you say, I want to spin up this resource or that resource. Maybe you grab a CloudFormation or a Terraform template, which is code that you don't have to get all that creative. They will say this spins up these resources, right? And you deploy that in, and of course then that means that physical resources are spinning up, so you've got storage and compute and databases that are now, they have a back end that we are maintaining. What it really means as you experience it as the user is that now that you have infrastructure as code, you can have security as code, you can encode policies as logical formulas. It changes your approach so that you no longer have to be thinking, is this cord plugged in? And you can now be reviewing your code for security, and you can also enforce things from a mathematical sense. Elastic security automation. So the fact that everything is an API, right? This means that you get a ton of visibility. You can look in your CloudTrail logs. You can see what you did or what was attempted. But you can also automate everything. So we'll talk a little more about automation as a product of kind of being cloudy. But this is definitely the kind of one of the elements of like welcome to the future. Runtime security. So tag-based targeting, folks in here who are on the ground level, hopefully you're looking at metadata around your artifacts and things like tagging regimes. That's something to put a pin in. I'm happy to talk more in depth about. But folks started out with it as a billing mechanism. It's super useful as a security tool to be able to maintain visibility around your architectures and be able to enforce actions and non-actions immediately. Rip and replace architectures. So, your web server gets popped and you kill it and spin up a new one, you haven't solved your problem, right? So thinking cloudy, this is something that everyone struggles with, even Amazon. How do you get at the root issues here in an environment where you can do rip and replace architectures? Continuous pen testing. So for folks who are on dev teams, integrating security into the way that they do business. You can use tools like Jenkins that will validate that you have deployed code that fits with your security environment, but you also probably are moving towards a DevSecOps model. No one likes that term, but it's the best one we've come up with, right? To imply that you don't get to just do perimeter security after the fact, right? The way that we are thinking about security, the way that it operates now is not to build bigger horses. We're talking about integrating decision-making from the ground up, and it means that your developers also need to be conscious of security and to be building towards security as one of their operational goals. So security is a bottom line decision here. And then finally, immutable infrastructure, so validation and enforcement and integration with managed services. When AWS has managed services, those are ones where your security responsibility model is actually going further up those layers of the stack. So you've got, not just Legos, but a Barbie dream house that you've built out of the box or whatever. And being able to integrate with the managed services as you deploy them.
And one thing that I would add too, so is anybody in here aware that Navy ERP migrated successfully into Amazon GovCloud this year? Anybody use Navy ERP? All right, a couple hands. Yes, a couple folks put in their timesheets today. So a really neat story about Navy ERP is, so it did migrate successfully into GovCloud. They had planned for 24 months for the migration time period. Very neatly, it actually ended up taking half the time. So they were able to successfully migrate this absolutely behemoth application into GovCloud in about 10 months. And one of the lessons learned after the migration was complete was just the uniqueness of the visibility across the entirety of the application once it was running in the cloud. Before, it operated in 9 separate data centers, which is 9 separate sets of servers and storage that may not have been the same product, may not have had the same security tools in place, certainly were managed by different people and different sysadmins. And now all of a sudden it's 100% in the cloud, and they have visibility across the entirety of that application and the ability to control access to an extraordinarily granular level just because of these infrastructure as code policies that can now be enforced in a homogeneous environment. So a pretty unique capability once you think about being able to have all your resources behind a true single pane of glass.
Cool. On that note, so infrastructure as code, we've got some examples here of like CloudFormation template that you could grab. And this is what I mean by it. So when you have infrastructure as code, then you can enforce security as code. These are IAM policies. You can get very granular about your identity and access management. So allow only these actions under these circumstances, under these time periods, right? And then you can enforce that. So does anyone know who this is? It's Euclid. So this goes back at least as far as Euclidean mathematics and the infinitude of primes. So no one goes out and tries to count every prime number. We just accept it to be true that there is an infinite number of prime numbers, right? If what we believe to be true about math is true, then there is an infinite number of prime numbers. Similarly to that, we use formal methods and formal math to validate what we think about networks and to be able to scope down problems and get conclusive answers. So the way that we use it at Amazon is you can scope down questions to be able to have a computer parse it. So in orange here are the ways that we use it internally. We use it to verify that our boot code is correct. We use it to verify that our crypto is correct. And then on the customer side, we have tools that utilize this. These are like just classical math truisms. So Zelkova is a tool that will compare our IAM policies and tell you authoritatively which one is more permissive. As you know, if you're working in identity at all, it gets confusing with roles and users and then with resources that can all have policies attached to them. So being able to have a computer parse those and kind of elevate the true kind of signal to noise there is something that is better done by computers and that uses these kinds of formal math. And then Tyros is a network reachability tool. It's now part of Amazon Inspector. It can tell you authoritatively things like, could you have an internet-facing endpoint in this network? Looking at your architecture, it can parse the math and actually tell you authoritatively. Of course, this is really useful to be able to extract insights, to be able to do alerting. It also gives you continuous auditing. You can point to your auditors to the fact that this is a formula that you can satisfy. And this is stuff that you can only do in cloud because, again, you don't have a rogue server under your desk or worry about whether something is plugged in. You're interacting with infrastructure as code. Another of the kind of cloudy elements that we're playing with here in security is the fact that you can automate so much. So I referred a little to DevSecOps. Part of that comes from the fact that you will have constructed your security controls in a way that you have minimized the amount of human manual interaction, right? So all of these on the left side here are just things that could be inputs into an automation. How many folks have like an Alexa or a Google whatever in their house, home? Yeah. So those under the hood, those are running a Lambda function. And it's just a simple automation. You can write your own scripts. Go online and you'll see you can write simple ones. So these are, simple lines of code, but they basically, this core use of automation is something that's very cloudy. And what it means is that you get to the point, hopefully, with your security, where you have minimal kind of gray area. So our SOC is a guy with a cell phone. Because everything has been automated, you've done the decision making ahead of time. What are the injects that we're gonna take that, let's say guard duty findings, how are we gonna remediate those? That's our IDS, IPS technology. So what do you do about it? How do you action the kind of dashboarding you're getting? And one of the differentiators in cloud security is that you can automate so much here. I mentioned security controls. This is going to be, again, something that you might have done on premise, but it will look different in cloud. So these are 3 categories of controls that I think of: protective, detective, and reactive. Reactive would include those Lambda functions and automations, as I mentioned. These are questions that I ask customers. This is not the gospel. This is just Merritt Bear's view of important security questions. So, at the outset, what are you just willing to disable and enforce? Do you have executive sponsorship that you can get political buy-in to the decisions that the security team makes around what you're going to allow folks access to, for example, as you develop? And what are your crown jewels? Maybe those decisions would look different if you're concerned about minimizing access for certain things. Detective controls, that's your logging and monitoring, right? So what are you using as your source of truth and how are you making those actionable? And then in responsive controls, how are you automating? These look different in cloud, but these are kind of foundational multi-layer defense that we would be talking about, but with cloud, you can do it in a different perspective with more visibility, with more automation, and using tools like formal math. These are the stages of the NIST cybersecurity framework. So this charts with some of what we would expect to see as we walk through those security controls, from identify to protect, detect, respond, and recover. So, starting out with what you're just going to allow folks to do, everything from IAM to, let's say, your service catalog. So maybe you don't have any folks who need to use certain tools. You can whitelist and blacklist, access to services as part of your security strategy. Working all the way through from your logging and monitoring, which is kind of the lifeblood of most SOCs, to responding and recovering. Do you have incident response runbooks? Do you have executive buy-in for what happens? How does an email turn into a trouble ticket? What are you doing with the last month of trouble tickets? How are you automating those? These are all questions that should be integrated into a sophisticated security plan. I mentioned this a little bit earlier, but our custom hardware is a really cool part of this story. So the Nitro System, again, we started talking about this in 2017-ish. You can look up YouTube talks. But there are some really neat elements of the ways that we have taken what were traditional security problems and been able to actually address them using custom hardware.
Just real quick on the Nitro System as well, that is one of the services that was just accredited for impact level 4 and 5. So our customers are able to use our Nitro Hypervisor now at this point.
And this underlies all of EC2. So if you are using, straight EC2, if you're using containerized services, if you're using, anything that has compute as part of it, this underpins it. So you're benefiting from these kinds of security benefits. Again, it's something that we could spend lots of time talking about. I think it's super sexy. But custom hardware has been, a long kind of pain on folks, especially in the security domain. We're talking about noisy neighbor and side channel attacks. We have externalized a lot of those issues. So it's something to look up or come talk to us about in more detail. But it's one of the things that you are benefiting from when you're using AWS is that you have not inherited all of the legacy hardware that usually comes with insecurities. Now we're going to talk a little bit about some examples of use cases, especially within the kinds of contemplated scenarios that we're talking about this week. So in particular, looking at some humanitarian assistance and disaster response.
Okay. And so one of the things that we'll highlight here, so we talked a lot about our global infrastructure, but we really haven't gotten into is the services themselves. So today, Amazon has over 170 unique services that customers can leverage to do use cases of almost anything imaginable today. So one of the services that we have, which is very notable to our DoD customers, is our edge computing device. Is anybody aware of the Amazon Snowball? All right, a couple folks. I'd offer, if you can, and you wanted to make your way over to TechNet at some point this week, we do have a few Snowballs at our booth to be able to give you a sense of the look and feel of them. But it's a pretty cool product that is being leveraged by the DoD and ICE community in operations today for some pretty exciting workloads. One of the things that we are creating around that device is the ability to have a service specifically related to disaster response. So when you go into an area, which obviously just had a challenging circumstance like an earthquake or a volcano or a flood, comms may be a real challenge, network connectivity may be a real challenge, and data sharing may be a real challenge. So being able to bring a small form factor ruggedized device out to that edge to be able to create things like a Wi-Fi mesh network and be able to leverage services like Amazon Recognition to be able to look at folks that could potentially be in collection areas to be able to identify them, or even kind of cooler, we did when we had some hurricanes back in New Orleans and folks had lost their pets. We were able to run our recognition software against pictures of their dogs to be able to reunite people with their pets. Right, kind of a neat scenario to be able to actually leverage these services, and all of it is done again behind just a single pane of glass. And what you're able to do is really just up to your imagination. So we'll talk a little bit about how that can look and feel when you actually get out to one of these HADR type scenarios. But it really all does center around the fact that the cloud and these services can operate in a disconnected environment using the Snowball Edge.
So this is a map of the architecture and what it might look like. As Hayes mentioned, these kind of exist now. These are building blocks that you can be putting together as we contemplate coalition interoperability, use cases. These are using the building blocks that we have available. So this is one that explains some of the elements of connectivity that you might be taking advantage of in a disaster response scenario. Is there anything you want to highlight?
Yeah, and some of the things to highlight. So, we talked a lot about the actual network connectivity between the regions themselves, but getting to the services, we have the ability to meet you in more unique ways. So we have another service, and again, one of the standalone out of the 170 called Amazon Ground Stations, where we actually have satellite dishes at our regions to be able to connect to satellite feeds and directly downlink data inside of our region so that you can make use of that data much faster than you would if you had your own managed ground station that was in a disconnected environment that then had to traverse into the cloud. So that is a service that is being rolled out at both our sensitive regions and then with plans to roll out to the commercial area, with also a planned satellite dish and edge location coming to Hawaii as well. So that's something that is underway today to be able to actually develop that capability. And so, to talk about the fact that there's going to be lots of different ways to be able to need and access that data. If you have access to the regions from a network physical connection perspective, you can use that. If you don't, you can operate in a disconnected state using Snowball. And then if you do have satellite feeds, you can actually operate inside of the region that's closest to you just via SATCOM. You want to talk about the Open Registry?
Yeah, so the disaster response program obviously takes the form of a lot of things, from people in response to information and technologies. One of the cool things that we have is that we host an open data registry. So if you go to this website, you will see that we have basically aggregations of open data sets that we host that are relevant to disaster response. I recommend that you check these out. There are some that are particular to this region. So you could be using them for training data or for teaching. You could be using them to inform your modeling, et cetera, and you can contribute back and forth. We are hosting it, but it's related to GitHub as part of sort of the open source community.
And kind of back to the Snowball Edge operating as the disconnected state. So one of the things that we were able to show this year at the Exercise Pacific Endeavor in Papua New Guinea was a set of snowballs being able to leverage services for a disaster response. So the snowballs themselves can be clustered into groups of 8. We call that a snowman, right? We're very creative with our marketing. And so the snowballs then can be used as a shared storage device and then also be able to run these compute applications. So one of the things we showed was the ability to run our call center service called Amazon Connect to be able to have communications in a disconnected environment so that folks can actually call and reach out to what would be considered kind of the command center there. So that's just another one of the services that can be deployed at the edge to be able to have that connection to allow for more effective communication and response.
This is one example of a use case that we had where folks at NASA were using AI to automate wind speed automation or estimation.
And,
you want to talk more to
it?
Yeah,
and again, kind of back to the fact that it's all cloud services that you can leverage behind a single pane of glass. So using our AI tools, they were able to automate manual calculations for estimating hurricane wind speed. So we have a set of services, and we're actually going to talk about them a little later this afternoon over at TechNet around artificial intelligence and machine learning. I think one of the most notable is Amazon SageMaker, which is a managed machine learning platform where you essentially just feed your data into the pipeline, select the framework that you want to leverage, and you can design algorithms for almost any use case that you can imagine. And you can see the customer base that we have at the start of the conversation. They leverage our machine learning capabilities in extraordinary degree today. And so kind of stepping back from machine learning, but going into just high performance computing in the cloud. So we do work with weather modelers across the DoD branches. In my own personal relationships, I support the Fleet Numeric Center up in Monterey, and they run their NavGem model today using Amazon high performance computing technologies inside of AWS GovCloud, with plans to potentially expand that out to a Neptune model, which is a global geographic weather modeling prediction service. So to be able to actually train these algorithms to do really advanced prediction is pretty neat. But so the group out of FinMock, the story they like to tell is in 2017, there was a record number of hurricanes, and they were at capacity inside of their data center to be able to run the predictive models against all the hurricanes that were in the Atlantic. And in order to get the capacity that they needed, it was going to be something like $3 million. And then you can imagine government contracting being what it is, the time it would take to get those servers, to get them installed, get them staged, get them networking, and get them useful was going to be well past the hurricane season, probably even past the hurricane season of the next year. So they came to Amazon, they said, we'd like to run the models in the cloud. We helped migrate the model into the cloud, and they ran it for all the hurricanes above and beyond the capacity they had in their data center for $9,000. So going from a $3 million outlay in many, many months, going to immediate access to the resources, and basically going to a rounding error on a DoD contract. So something to consider.
Similarly, these are some use cases that we have also seen folks use when you're using these edge environments. One to map disease in Africa, and one doing California wildfires in 2018, and then would be this year as well, unfortunately.
Great, so we'll talk a little bit again about the Snowball device. So the Snowball comes in a few flavors. So we have the traditional Snowball, which is just used for data migration, and that's really where it all started, to say that networks, and you guys can probably relate to this better than most, but networks can have low or slow progress getting data up into the cloud. And so in order to help solve that challenge for our customers, we created this device called the Snowball, which started out as 50 terabytes, grew to 80 terabytes, and is now 100 terabytes of a ruggedized encrypted device to be able to do batch transfer of data up or down from the cloud. So our customers were using that for a pretty significant period of time, said we loved it, but we'd love to be able to do just some basic data manipulation at the edge. Can you put a little bit of compute on board? And we did, and that has evolved into the Snowball Edge family of products. And once you have something that has compute on board and it's ruggedized and people can use it, they want to be able to use it for longer than their original business case of just transferring data to and from the cloud. So we now have the ability to allow DoD and any customer, but DoD customers for you guys specifically, to leverage this as a managed service for a 1 or 3 year period. What's unique about that is because you don't buy this device outright, you're never challenged with the forward new features and not being able to have access to them. If you're using this device for a few weeks and it fills up and you want to send it back to the cloud and you request a new device from us, and just from a general managed cycle, you will get the latest and the greatest Snowball and the latest and the greatest features of the Snowball. If you're interested, there's going to be some really cool announcements that are planned for Reinvent this year in about 2 weeks that are going to significantly improve the capability of this device and make it even more attractive to DoD customers. From my perspective, working with NAVWAR, we have some use cases today that are actually supporting folks in this area. So we have folks out of PMW 120 and PMW 160 for the Canes group that are evaluating Snowball Edge to be able to see if it can be used as a Canes attached device to be able to deliver applications more quickly out to the ships in a disconnected state. And then if you go on, we have the Snowball 100 terabytes. That's great. You can order a bunch of them at once. So we call it petabyte scale. But if you really need to move a lot of data, we actually have the Snowmobile. The Snowmobile is an 18-wheeler truck, which I believe has 100 petabytes.
Yeah.
100 petabytes of storage on board, and allows customers to do just a really quick batch update to the cloud. We do have IC customers that have used the Snowmobile in the past to be able to get their data sets up into our secret and top secret region. So pretty neat to have this parked at your data center and then see it drive across the country and then be able to access 100 petabytes of data inside of the cloud and as quickly as just a road trip for a trucker.
If there are security folks in the room, you'll want to know what are some considerations around the security of these devices. So just some considerations to keep in mind. There's tamper evidence built in. It's fully encrypted, so you have to have the KMS cloud key and the TPM in the device, and you need both keys present for the device not to be a brick. So when it's on the road without authorization, there's no way for folks to be tampering with it. We do not deploy into the API the manifest file until the shipper confirms delivery, and then triple layers of AES 256. We can talk more about the security of the device if you're curious, but I couldn't resist including some security in our conversation.
Yeah. And for this group as well, so the regions that we have for sensitive data, right, GovCloud, Secret, and C2S for TSSCI, we have inventory of Snowballs at each one of those areas. So if you are moving secret data sets, you would obtain a device that is accredited by either DoD or ICD 503 to host secret workloads or have secret data in transit. The device would originate in the region that you select. So if you have secret data, you would select the secret region. The device would originate from there. We use secure couriers. So we either use Transcom for TSSCI, or we have secure couriers relationships with FedEx and UPS to be able to deliver that out to the edge. Once you have the device, you can connect it to secret networks, make use of that device for however long you deem possible or deem necessary. Once it's completed and is no longer either useful to you or you want a new device, you would send it back, and the only place it can go is back to that region that it originated from. One of the, perfect, we've got the picture up here. So one of the cool things you'll see on the top is an actual Kindle. So Amazon, we've got a lot of Kindles, so we figured we'd slap one of those on the device to make it easier for you to not have to worry about printing labels. What we found is that, I would probably be just as guilty of this as anyone, but shipping something can be a challenge. You show up to FedEx, you've got your shipping label for your kid's Christmas present, you've got your shipping label for the device you want to send to Amazon, you accidentally switch the two, and we get a bear and your kid gets a hard drive. Right? Doesn't sound like a lot of fun for the kid, definitely confusing for us. So we made the Kindle e-ink reader on the top only have a ship to and a ship from label. So you can move the device as you deem fit when you have it in your possession, but when you want it to go to Amazon, the only place it can go is to the region that originated from. And when we send it to you, the only place it can go is the location that you decide when you order the device itself. So we have the ability to leverage the Amazon.com logistics philosophy to make this very simple so that it gets to you as you want it to, and if it has any secure data on it, you can be confident using secure courier and the fact that it can only originate and terminate in one location. Okay. And then so the services that we have, like I said, the unique thing about this device is, again, you don't buy the Snowball. So the Snowball is a managed service from the cloud, exactly like if you're using compute or storage inside of the cloud, it's the same, but it just happens to be a physical device that can operate in a disconnected state. So we give you the opportunity to use services that you would get in the cloud on the device itself. So things like our IoT services, our very light IoT operating system called Greengrass, Lambda, which is our serverless execution of code as a service functionality, operates on the device. EC2 and EBS and S3 operate on the device as well, and then plans for many more higher level services that are extremely relevant to the DoD in the not too distant future, which is what we'll announce at Reinvent. Do you want to
keep going?
Yeah. And in this AOR, and I will definitely not pronounce this correctly, but everyone is probably familiar with the Big Island volcano eruption. So there was an area that had 40 years of historical geographic data in a data center with lava approaching it at a rate of whatever lava flows at. And they were really worried about this data. They didn't have backups. So they came to AWS and they said, can we use your Snowball device to be able to move this data so that if it were to get to the point where the lava reached this, we would still have access to this very important historical geographic data. And so we sent out, I think, 2 Snowballs, right? So 100 terabytes, uploaded 40 years of data, and we're able to move it into the cloud to be able to prevent a disastrous scenario like that. And again, all of this happens at the click of a button when you request the device. And when the actual original Snowball, which is just used for data transfer, is only $300. So they were able to save 40 years of historical geographic data that was extremely important to them for about $600. Pretty cool. And we mentioned this a little bit earlier in the ground state or the disaster response portion, but the Amazon ground stations is our managed ground station service, which customers can leverage to be able to download data directly into an Amazon region. So for humanitarian and disaster response efforts, you can imagine that could be pretty beneficial, but then even more so for DoD operations, right? You always hear about how challenging it is to be able to get data to and from ships when they're operating inside of these these AORs, and they're 3,000 miles out in the Pacific Ocean. Being able to tie directly into our regions via DoD SAT communications is something that is planned. So not something that we have the ability to connect to today, but due to our relationships with DoD and IC, we would look to be able to leverage that capability to be able to more effectively allow you to interact with your data if it resides in the cloud and you're in an area where you couldn't get back to one of our sensitive regions via terrestrial networks.
Cool. This is the kicker. We're getting to the end here.
That's right.
So, yeah, this is just one more use case. A partner of AWS, Robotics, worked with the Peruvian Air Force and captured post-incident aerial imagery to compare with pre-incident using drones, using imagery captured by drones, being able to do it in a deployed network, as we mentioned. Anything else?
And so what we love highlighting about this specific use case is there's so many contributions from an operational perspective here. So drones flying, right? We have a service called RoboMaker that allows you to train unmanned robotics, right? And that is being leveraged at the scale that customers that use Amazon could potentially leverage, right? So if you think some of the pretty significant unmanned robotics organizations out there, the ability to do video transcoding. So we have a product called AWS Elemental that can take the drone feed and multicast it directly to whatever device you want to point it at. That is also a service that can just be automated and leveraged. Then the recognition services, to be able to train an AI algorithm to be able to say what is the current state and what is satellite imagery in the past state, to be able to detect where major differences occurred so you can focus your efforts. So you can see just by being an AWS customer, you can be able to take on pretty significant challenges in a challenged and disconnected and potentially operationally difficult environment simply by having access to the services and being able to point your data at the services. So we certainly hope that this has brought some, I guess, thinking to you guys and be able to think a little bit about how the AWS services can support you for your specific events. We can take the opportunity now to open it up to questions. We'd love to be able to dive a little bit deeper into anything that you have.
Any questions? Yeah.
Please shoot. Sorry, can you ask that question one more time? We don't, and that's certainly a much tougher nut to crack. So we don't have that capability today.
Can you explain the question?
Oh, sorry. For those that didn't hear, the question was: we have a low to high diode service or cross-domain solution that we offer as a managed service. Do we have either one in existence today or plans for a high to low? The answer to that is we do not have one today. From a planning perspective, I don't think anything's out of the realm of possibility for Amazon, but nothing that we would share publicly.
And if you have a use case, come bring it to us and we'll put in a request.
Yep.
Yeah.
And that I love that we brought that up. So one of the really great things about working for Amazon is 95% of our services are created based on specific customer feedback. So as we interact with you and we learn, things that are important to you or challenge areas that you have across our services, we incorporate that feedback very quickly into offering either brand net new services or features to additional services. So we'd love to understand, a little bit more about what is important to you in that scenario and see if we can bring it back to a service team. Great. You got a couple minutes?
No, I'm just going to make that.
Okay. I apologize, we went a little bit over what we were planning to, but we actually did have a demo from our Elemental team to show the work that we did with Enterprise Challenge, being able to do effective drone video feeds to a Snowball edge. So we have Matt Carter from AWS Elemental just to give a quick overview.
Yeah. I won't be able to go into the slides today, unfortunately. We are out of time. It was a wonderful presentation, by the way. So, but if you do have a chance to stop by the booth over at the Indopact show across the street, please come by and take a look. We're actually running a lot of the AWS Elemental services on Snowball. If you're not familiar with AWS Elemental, we are the video services overlay for the larger AWS platform. And we're basically taking a lot of the technologies used in the commercial over-the-top delivery streaming markets, such as Amazon Prime Video as an example, and rewrapping that in a way that's being utilized in DoD and IC workflows. So if you do get the opportunity, please stop by. I would love to take you through a demo and show you some of the architecture and what we did at the Enterprise Challenge event. Thank you.
Great.
Thanks, Sam.
I think we're wrapping up, but
All right.
at 2, I think we mentioned 2 to 3:30, we are talking in depth about AI/ML, and we'll talk some more about security there as well. So please come seek that out if you have an interest, and feel free to come to us individually as well. Thank you.
Yep. Thank you, everyone.
So thank you very much to both of our speakers today. As a sign of appreciation for your time and your expertise, we just wanted to let you know AFCEA will be making a donation in your name to the Toys for Tots Foundation. And the Hawaii chapter would like to present you with a coin.
Thank you.
So thank you both very much. We appreciate it.
Thank you so much.
All right. And this concludes this session. We'll be back here at 1 o'clock. So if you are interested in having attendance documentation for your cybersecurity continuing education credits, please do have your badge scanned here in the back of the room. Thank you all very much. Thank you.